I'm Michelle Kittleson, heart failure transplant cardiologist at Cedars-Sinai in Los Angeles, California. We're joined by Dr. Yuk Law. Dr. Law is director of the Cardiac Transplant and Heart Failure Service at Seattle Children's Hospital and professor in the Department of Pediatrics at the University of Washington School of Medicine. So let's start with pathophysiology. Can you explain the current model of immunopathogenesis of myocarditis and how an understanding of this basic science impacts clinical decision-making?
I think it is always important for clinicians to have some idea of the pathogenesis, even if it's not been proven, for example. So a lot of the information that we put into the statement is from animal models. Unfortunately, we don't have that kind of scientific evidence to say for sure this is what's going on in humans, for example, adults or children. But there are some well-known mouse models that study the pathogenesis of myocarditis, assuming it really is a viral hit, a viral myocarditis, which we believe it is epidemiologically in children anyway. Assuming that's the case, there's certainly an infection, a cytopathic triggering of injury to the myocytes. And then the question is, what happens? I mean, is the virus just going to destroy the entire heart? It doesn't seem that's what's going on for most myocarditis where we do have autopsies, for example, where there's no virus left anymore. But then what happens after the infection of the heart? We believe that there probably is an innate immune response that's already built into the immune system, for example, that identifies the certain patterns of recognition of viruses and other pathogens too. It doesn't have to be virus. It's the immune system's ability to defend itself in the front line without any sophistication, without any commands, any generals in the background telling the troops what to do. It's a frontline defense. And once that begins, it gives time for a secondary response, T cell, B cells, turns on the memory system of the immune system. And I think what happens along the way, there is some kind of crossfire going on. There's certain mimicry or certain antigens that are previously unexposed or not exposed in a way that tells the immune system that this is actually something that we want to get rid of. And some of these antigens could be HLA mediated, could be antigens related to myocyte endothelial cells that are always there. They're not new antigens, but they're always there. That somehow the inflammation and the triggering of these immune responses lead the immune response to now start attacking the myocyte or other tissue components of the heart. The other possibility is that none of this exists, that it is purely cytopathic and that there's enough injury to the myocytes, that enough myocytes are damaged, that they do not repair, do not regenerate, such that you're left with an injured heart.